Okay, so far we've covered two of the key index rules. That if you multiply two items with exactly the same base, notice that say it's identical base here and here, A, or identical base here and here, X, that you just add the powers. And if you're dividing identical bases, you can take away the powers. Now, what we need to do is look at why something to the power of 0 always equals 1. And I'm going to do the proof of why that works now. So, first what I'm going to do is I'm going to say x to the power of 3 equals x times x times x. Now what I'm going to do is divide by x to remove 1, and I'm going to end up with x squared. So x times x gives me x squared. Now I'm going to divide by x again. So x divided by x would equal 1. So I'm left with x times 1, which would give me x. And again, if I divide by x again, x divided by x would make this one become 1, but I'm still left with 1 whole x. Are you all happy with the concept when I keep saying x divided by x equals 1? So look, x divided by x, this one here would become 1, but now I'd have 1 times x, which would give me x squared. And then if I do x squared divided by x, this x divided by this x would become 1, so I'd have x times 1, which gives me x. Now this is the most important one, so I'm going to do it in a different colour. X to the power of 0 equals x divided by x, because again I'm going to take this one and divide by x. Now what do we know that x divided by x always equals? Well, we've just talked about it here. So this rule that we've been using all the way through to simplify our answers actually gives us the one we want, that anything to the power of 0 will always equal 1, because you're taking that base and dividing it by itself. And this actually this pattern beautifully describes negative indices as well. So if we take x to the 0 and we divide by x, we're going to be following the same pattern. We're going to be taking away a power, so we end up with -1. So now we have the answer of 1 divided by x. If we divided, so we have x to the -2, that would be 1 divided by x times x, which gives us 1 over x squared. Now at this point, it's a really useful word to introduce called the reciprocal. And a reciprocal is when you flip a fraction. So for instance, if I had 4 over 1, the reciprocal of it would be 1 over 4. So why I'm telling you this is, if you see a negative value, that just means the reciprocal of that normal power. So normally x squared would look like this if we wrote it as a fraction, because it's something divided by itself, it's just itself. Sorry, say it again, something divided by 1 gives you just itself. But if I wrote negative x, so -2 rather than x to the power of 2, I would actually have the reciprocal of x squared as a fraction. So it would be 1 over x squared. So whenever you see a negative value, that just means that you've got the reciprocal of the normal index. And that's about it, really. The things that you need to understand are that anything to the power of 0 is always 1, and anything that is negative is the normal the normal power turned into a fraction and then flipped. And that's called the reciprocal. So a negative gives you the reciprocal of the power, and a 0 index always equals 1, because what it's calculating is your base divided by itself, and anything divided by itself is 1.